Hello everyone. Today I will discuss about conservation of momentum. Conservation means it is a constant and momentum means it is the quantity of motion or amount of motion contained in the body. So we all know that the momentum P is equal to mass times velocity. So the conservation law states that if there is no external force acting on the system, then the momentum remains conserved. So from Newton's second law, we also know that the F external force is equal to change in rate of change of momentum dp by dt. Only force is equal to rate of change of momentum dp by dt. If no external force, that means F external force is equal to 0. So this will be equals to 0. That means dp by dt equals to 0. That implies from derivative we know that P remains constant. So how can we prove this? By taking a system of bodies. Okay, so by taking a system of bodies, suppose we can take a system of the simplest system, that is the system of two particles. Okay, so if we take the system of two particles, suppose two particles A, one particle is A and another particle is B. A having the mass m1 and velocity u1, and B having the mass m2 and velocity u2. Okay, when these two particles collide, when the velocity of u1 is greater than the velocity of u2, if they having the same velocity, then we will not collide. So here the assumption is, that is the u1 mod is greater than u2. Okay, this will be the assumption. So now these two particles now collide. When the two particles collide, one exert a force on another. So this particle, suppose A, B, this will be 1, 2. So suppose A exert a force on B, that will be F21. Similarly, B exerts an equal and opposite forces to A. This will be F12. This will be a force on one particle due to two particles. So after collision, A moves with the velocity another velocity and B moves with some another velocity. Suppose A moves with the velocity having mass m1, moves with the velocity v1, and B moves with a velocity having mass m2 with a velocity v2. This is before collision. And this is after collision. Okay, now come to the important point. We have to prove that the momentum remains conserved. So we have to find out the individual momentum of the particle. So the particle before collision, the momentum, suppose particle A having the momentum Pa, which is equals to mass time velocity. So this will be m1 u1, and momentum of B, similarly Pb, equals to m2 u2. And after collision, A having the momentum Pa prime is equal to m1 v1, and B having the momentum Pb prime is equal to m2 v2. Okay, so from Newton's third law we know that if A exert a force on B, so B also exert a equal and opposite force on A. So F12 equals to negative of F21. And we know that F is equal to dp by dt, change in momentum with respect to time t, rate of change of momentum. So if we apply this momentum in this equation, then what will be the equation? If we write it here, so F12 will be the change in momentum of A. So momentum of A is changing from Pa to Pa prime. So this will be Pa prime minus Pa in a time t, suppose. And B also F21, that means the change in momentum of B. So B is changing with a negative sign is here. So B is changing in the momentum from Pb prime Pb divided by t. So cancel t both the sides. So now Pa prime is equal to m1 v1. So this will be m1 v1 minus Pa will be m1 u1 m1 u1. So similarly pb prime is equal to m2 v2 minus this will be m2 u2. Now rearranging this equation, so m1 u1 vector plus m2 u2 vector is equal to m1 v1 vector plus m2 v2 vector. This is the momentum, the sum of momentum of individual particles, that is the A and B. So this is the system having the momentum before collision, and this will be the system having the momentum after collision. So we can say that this will be the initial momentum is equal to this will be the final momentum. That means the momentum remains constant. So we can prove that for a system of particles, if there will be no external force, this will the between the collision, here no external force is applied on the system. This will the internal forces. So here the momentum remains constant. So we can take the example of rocket propulsion or the recoil velocity of the gun. This is the very important concept, that is the conservation of momentum.